Well, it's a very good afternoon and welcome to this lecture on AI, climate change, friend or foe. My name is Geraint Rees and I'll be chairing this session. The lecture is part of UCL's climate campaign, Generation One. Together, we're the new generation, taking responsibility for climate action and turning science into actionable ideas. We'd welcome all of you joining Generation One in a number of easy ways. You can pledge your climate action, finding out more about it at ucl.ac.uk/generation1 and choosing what action you'll pledge. You can inspire others by sharing your pledge on social media. Please tweet from this event if you're enjoying it using the hashtag UCLGenerationOne. And you can also check out our new Generation One podcast series as details on the website if you'd like to take advantage of that. Now, in this lecture, we've got three very exciting speakers who I'll introduce in a short while. We're going to have some time for questions at the end. So please do get busy submitting those questions. You can go to Slido, that's sli.do, and entering the event code, which is #UCLClimate. We'll look at those questions at the end, and I will put them to our three distinguished speakers, who I would now like to welcome. To introduce them each in turn, first, we've got Professor Kate Jones, who is Professor of Ecology and Biodiversity in the Department of Genetics, Evolution and Environment, which is part of the Faculty of Life Sciences here at UCL. Professor Jones is a world-leading ecologist, and her work focuses on crossing disciplinary boundaries to address critical global challenges, especially those that are at the interface of ecological and human health. But she's made key advances in monitoring the status and trends in biodiversity, and particularly in modelling and forecasting zoonotic disease outbreaks in human, Ebola, SARS, and now, of course, COVID-19. And this kind of modelling breaks down traditional barriers between ecology, climate change and public health to inform global policy. She's also a scientific advisor to UK's Climate Change Committee, which is an independent body that tracks the status of the UK government's progress towards those goals. She will be our first speaker, but I'll just introduce the other two. Sir Geoff Mulgan is our second distinguished speaker. He is Professor of Collective Intelligence, Public Policy and Social Innovation here at UCL. Sir Geoff was the Chief Executive Officer of Nesta, which you may know as the UK's Innovation Foundation from 2011 to 2019. Earlier, before that, from 1997 to 2004, Sir Geoff also had roles in UK government, including being Director of the Government Strategy Unit and Head of Policy in the Prime Minister's Office. And then finally, we have Aidan O'Sullivan, who is an Associate Professor in Energy and AI at the UCL Energy Institute and a Turing Fellow at the Alan Turing Institute. Before joining UCL, Aidan was a postdoc in machine learning at MIT, and his research focuses on applications of AI that accelerate decarbonisation of the energy system. He's Programme Chair for the UNESCO International Research Centre on AI Climate Change Programme, and the Chief Technology Officer and co-founder of a very exciting UCL spin-out called Carbon Re, which is applying AI to a variety of foundational industries to improve energy efficiency. So on behalf of all of you, I'd like to welcome our three distinguished speakers. We'll now get going to hear what they have to say, and I'd like to introduce Professor Kate Jones as our first speaker. Kate.
Thanks very much, Gary, and thanks very much for the invitation to speak. I'm just going to share my slides. And so I'm an ecologist really at heart. And I really, when I got asked to give this talk, I really thought about the question and how it applied to my area of research. And so I guess I'm thinking about it with a kind of ecological lens. Is AI for helping climate change, is that friend or foe? And I would say, in summary, it's a friend with caveats. So let me just talk through my logic here. So one of the ways that we're going to try and approach the climate change challenge is with nature and not against nature. And there's a huge movement of trying to think about how we use nature-based approaches to tackle climate change. And that includes mitigation, which is trying to lower our emissions or absorb carbon that we're producing, but also adaptation. So there's at least 1.2 degrees warming already committed, possibly 1.5 by 2050. So there's a huge amount of climate change in the system that we cannot do anything about. And so there's a huge role for nature-based solutions for adapting to climate change. And so when I say nature-based solutions, these are, these have been defined, I've just written it on the slide here, but they've been defined as actions which, are managing and restoring our natural systems to address these big societal challenges. So, for example, they could be, for mitigation, for example, it could be planting forests. You could be planting broadleaf forests to absorb the carbon that's being emitted. It could be a coniferous forest, which is fast growing, or it could be a broadleaf forest, which provides more habitats for biodiversity, as well as for the carbon sequestration. Also, it could be restoring peatlands, which absorb a huge absorber of carbon. And when they're in bad condition, they emit carbon. So it's a really important way of thinking about how to manage our climate goals. And it's thought that nature-based solutions are a really key part of even meeting the mitigation targets that we have, let alone adapting to the ones that we have. So these are really important parts of tackling climate change. However, really big questions remain about what type of nature-based solution. How do we monitor these ecosystems? How do we monitor the carbon that's being absorbed or emitted? How do we monitor their health? And how these healthy ecosystems are really important for nature, for climate change and carbon capture. So that's where I think AI can really be a friend, is trying to understand how we're meeting some of these targets and how we're implementing and how healthy these ecosystems are. Ooh, hello. So I'm just going to go through some examples and then just come up with some caveats that I talked about before about, whether AI is a friend or foe. So this is an example from AI for Earth from Microsoft. And they've got a number of projects which are using AI-enabled observation monitoring. So this is a system for monitoring deforestation in the Amazon, which is a big carbon sink. And it's emitting carbon at the moment because it's kind of being cut down, or it's on fire. So this is an AI-enabled Earth observation monitoring system where we're using data from satellites, using some AI to then think about, deforestation risk map. So this is a kind of pipeline where you can then have these beautiful risk maps which policymakers can use to monitor some of these targets. So that's a kind of satellite-based monitoring system. But there are lots and lots of things which are going on under the canopy or in non-forested areas, which we really need to understand. So how the kind of communities change in response to degradation is really important. And these aren't captured by satellites. So this is a paper that was recently published by some colleagues of mine that looked at the intactness of the forest underneath the canopy. And as species respond differently to intensities of human pressure, as you can see on the right here, some species love degraded landscapes, some of them hate it, some of them tolerate it. So that's all happening underneath the canopy. And so just by monitoring by satellites is not going to help us understand how intact and healthy these ecosystems are. So there's a huge development in new technologies, new sensor technologies for ground-based monitoring for biodiversity and for ecosystems in general. And these are focused on two areas, which I'd just like to spend a bit of time on. Firstly is like images, so camera trapping. So these are cameras which are put out into the environment, and then their images are collected, and then you can use AI to use face recognition, but for species. So this is one that we have for Kenya, and this is obviously it's a giraffe, but we can go through millions and millions and millions of these images automatically to produce the classifications that we need, and that's how AI has been helping us do that. But also another aspect of the ground-based monitoring system, acoustics sensors, is acoustics. So by listening to the environment, you can tell what species are present, but also how healthy that ecosystem is. And that can kind of go from being in terrestrial environments, but also in the marine environment. So corals make sounds, and you can listen to corals, for example, to see how healthy they are. And AI has been helping characterize the sounds that there's been made from these environments and these species and classify those. So there's a real big classification advantage that you have when you're using these AI systems. You can also use them for whole soundscape or a whole ecosystem monitoring. And this is a project we've been doing in Borneo by looking at various remnants of forest, so either virgin jungle, but also different sizes of the forest that's been remaining after a company came in to do oil palm plantations. And you can use AI to be able to use deep learning to categorize these soundscapes and they categorize very well to the kind of size of the remnant patches and the state of these ecosystems. So that's a really cool way of trying to understand in a very broad way how healthy those ecosystems are, which is actually really interesting. So that kind of clustering and unsupervised learning for AI has been very important for us. But also just to touch on how this can be used for anomaly detection as well. So if you know what the sounds of the forest are, you can tell if something bad has happened, like a chainsaw. So you can pick up as an early warning system these anomaly detections like chainsaws or gunshots, if you know what it normally sounds like. So these have been very powerful in helping us understand how to monitor these ecosystems. So there's a huge number of AI-enabled monitoring that's going on at the moment. I want to draw your attention to this iNaturalist one over here. And that's a really big citizen science project where people are taking photos all over the world. And then these photos are enabling us to understand how populations are declining in different habitats across the planet. And those images are then being fed into a big AI, which it's called ImageNet, which is going to be used to identify species just from the images. And so people can take pictures on their phone and then you get a species recognition algorithm and identification. So those are really interesting and really, it's really expanding and exploding. I think that's really brilliant. But I guess I've got a few caveats. So these are my caveats. And that a lot of these systems really require that we have these huge amounts of data in order to work. And also not just huge data sets, but curated data sets. So we need quite a lot of labels. So we need these tests of what things are so that the machines, the algorithms can recognize what species they are. And often those aren't possible and it's not possible to do that. We need lots of cheap computing resources to actually process all of these algorithms. And we need them scalable so that we can maybe put them on tiny machines or tiny sensors in the field. And often a lot of ecologists aren't computer scientists and don't know how to use any of these AI programs. I'm not trying to do any ecologists down, but you need little expert knowledge in order to deploy these. I mean, the practitioners will want to deploy these with little knowledge of the systems, and so they need to be easier to use. And then I guess one thing is about whether it's just accuracy you want. So you just want the classification of the species and you don't really need to understand anything about the system. And so if you're trying to understand why it's being degraded or how to then make it predictive into the future, maybe AI will need to be supplemented with further statistical modeling. So mathematical modeling and forecast modeling to understand how you put some of those ideas from the AI into a more mathematical predictive forecasting model. So AI isn't enough on its own, and it means that it gets you so far, but actually understanding it as a tool, I think is really important. And it's just one tool in your toolbox in order to understand how to monitor and manage ecosystems for these nature-based solutions to climate change. So I just wanted to end on an example from my own work on disease forecasting. So this is just an example of what we were trying to think about, how to put all of these pieces together in terms to forecast disease risk. And AI plays a really important role in trying to understand how species are distributed across the world. But unless you feed it into all these other parts of the system, socioeconomics, the vulnerability, the exposure of people, you won't be able to understand risk. So that's what I want to say. It's a friend, but with caveats. Thank you.
Kate, thank you very much for a fascinating lecture. I'm sure that will have sparked off lots of questions in people's minds. Please do remember you can go to Slido, that's sli.do, the website, search on hashtag UCL Generation 1 and pose your questions that we'll come on to at the end of each of the talks. So we'll move on now to hear from Sir Geoff Mulgan. Geoff, please take it away.
Thanks very much, Geraint, and thank you, Kate, for a fascinating talk. I've learned a lot already. I don't have any beautiful pictures, I'm afraid, to share, but I will try and provide some angles on how we think about the friend and foe issues of AI and climate change. My background is that I have a PhD in telecoms, but I spent more of my life working in policy, and nearly 20 years ago helped on the UK's first climate change strategies, which I like to think contributed to the UK doing slightly less badly than most of the other big industrialized countries, and becoming a world leader in offshore wind came out of some of our work nearly 20 years ago. As Kate said, almost everything we know about climate change is a result of data and models of increasing sophistication, and therefore should be part of the solution. But I think we're in a very ambiguous position at the moment. On the one hand, as we'll hear, I'm sure, from Aidan, in fields like energy, there is huge potential for machine learning to optimize systems. Electricity is about a quarter of greenhouse gas emissions at the moment, and AI is well tailored to cope with intermittent supply from renewables like wind and solar, but also to help on the household side. A few years ago, as part of a project trying to use data and AI to make it easier for people to shift their, when they did their washing into the off-peak hours at 2 AM, so as to reduce loading, which in turn greatly reduces the need for energy production capacity. In transport, in a way, the story is even more striking. Imagine a city or a town with driverless cars, and therefore without traffic jams, cars idling, the huge waste of energy we currently have in our lorries and cars and so on. And agriculture is also seeing extraordinary applications of AI to optimize planting, pest control, etc., etc. That's the good side. The bad side, which is, I think, often a bit invisible to people, is the actual sheer carbon emissions associated with digital and AI. At the moment, about, I think, 3.7% of emissions come from digital internet activity. Estimates of the carbon footprint of individual machine learning training are mind-boggling. Dozens of times the lifetime emissions of a car, 60 times a transatlantic flight for some. And although there's been progress in trying to optimize the server farms which lie behind our internet and their extraordinary use of AI, some forecasts, a recent one actually was suggested that by 2040, 14% of all global emissions could come from computation if action isn't taken. So that's where AI is both friend and foe of the climate. So three sort of things which I think follow from that. One is about business. So to my mind, one of the strange things of the last 10 or 20 years is how slow digital businesses have been to really take climate change seriously. Apple was notoriously uninterested in anything ecological and allowed this extraordinary mountain of e-waste to grow up as people discarded their iPhones and iPads and so on. But Facebook and others were not much better. Amazon only very belatedly taking this stuff seriously. So applying the brain power of those companies, which employ now thousands and thousands of AI programmers, applying that a bit to the climate is long, long overdue. And a bit of a contrast to the world of investment, which admittedly it's still got a long way to go, but for many years its leaders have been advocating shifting capital reporting, investment reporting to take ecological issues more seriously. I think the leaders of the digital world have been remiss, and they were almost invisible in Glasgow at COP26 yet again. The second related point is in the public sector, the teams doing climate change work have very little connection to the teams doing digital and data and commissioning AI. And if you look at the city strategies for net zero or the national strategies, they're still not joined up with the sort of techniques and mindsets which are common sense for people working in this space. And finally, I think there's a sort of structural policy issue here, which is really, really important and vital that we get a handle on. And this may be where we enter some controversy. I think to achieve what is possible in 10 or 20 years, particularly in cities, of mobilizing data and AI to optimize our mobility, our energy, the logistics of our supermarkets and so on, we can only do that if the data is linked, if we can actually see the patterns suitably anonymized, and then use all the different array of AI tools to streamline, to optimize, to adjust the coordination of large-scale physical systems. At the moment, however, nearly all of that data is proprietary. It's held within electricity companies or Uber or bus companies and so on. And it's almost impossible to get hold of it, let alone to link it up. As a little experiment, try and find out all the relevant data where you're living right now about what is happening to energy or transport or anything else. You will find it's almost impossible. It's locked up in silos. Now, that was the business model of the 2000s and 2010s. It's what made Google, Facebook, Alibaba, Tencent, and so many other companies very rich. But I think it's become an anachronism. And we will need new ways of pooling that data, I think through various kinds of data trust, with shared governance, protections on privacy, because you don't want your neighbor to know when you're not using energy for a week and a burglar might break into your house, and many other privacy issues arise. But so we can actually mobilize the full potential of AI as a friend of shifting to a net economy and society. Now, we're some way from doing that. Europe is beginning to move in that direction in very different ways. China is, with its sort of city brain and other initiatives. But there is a bit of a sort of mindset block because the companies spending the vast sums on AI R&D at the moment obviously feel it's against their interest to pursue the structural policy changes needed for the world as a whole to reap the full rewards of AI and in all its potential. So that's a very political aspect of this, which we don't talk about very much, but I think is going to be essential to making progress on the, as it were, the everyday life, the urban side of the things which Kate was talking about. I'll shut up there, I think. Back to you, Gary.
Thank you very much, Geoff. Lots of food for thought there in that slightly interesting but controversial political area. Now, I must apologize for misleading all of you in the audience last time around with the hashtag for the questions on Slido. It is, in fact, hashtag UCL climate. I won't get used to all this hashtag stuff unless I read out my brief appropriately. Please do keep the questions coming. We'll have some time for some conversation at the end. So that's Slido and the hashtag UCL climate. But last and by no means least, Aidan O'Sullivan. Aidan, please take it away and tell us about what you have to say.
Thank you very much, Geraint, and thank you, Geoff, for preempting me. I think you'll probably find you're quite correct in your predictions. But yes, I'm going to talk about it from, I guess, a positive perspective of what's, why I think AI is such a critical enabling technology for dealing with climate change. So as a kind of a recap of where we are, so we've just completed COP26. There was a reference to it that I quite liked, which was our last best chance to take action on climate change. And, the positives coming from it is there's definitely a measure of international consensus, and the argument has shifted from, is climate change real to, what do we do about it, which is progress of a sort. And if we were to, again, think about where we are in the world, we're coming out of the COVID crisis. And what this showed with the kind of the push for the vaccine was, what's possible through international collaboration, through accelerated timelines during a kind of a war mode or emergency mode. We can make these big changes. So the kind of reduction in emissions that we saw during COVID was about 2.3 gigatons due to essentially the world shutting down. And that gives a sense of the scale of what we need to do. So if we look at the scenarios and the trajectory we're on course to hit 59 gigatons of CO2, which would push us into a 3.5 degree world. And where we need to be, as a kind of a minimum acceptable increase is a 1.5 degree world. So this is a 25 gigatons of CO2 world where we're emitting that. So the change that we need to increase, or the change that we need to implement, is of the order of 34 gigatons. And if the disruption of COVID only produced 2 gigatons, this gives a sense of the scale that we need to move at and the challenges we face. So in order to do things at that level, we need radical technologies, and we need our solutions are going to have two key characteristics: speed and scale. We need to take action now. So we need solutions that are able to deploy now, and given that emissions have a cumulative effect, action today is better than action tomorrow. But we also need scale. So our solutions need to scale to reduce emissions by gigatons. And my view on this is that these are two characteristics that AI embodies as a software technology. So as a solution for what we need to achieve, it seems to me to be a critical technology in the mix. So I work at the Energy Institute, and one of the things that we're deeply interested in, that we've been discussing for a long time, is rates of technology change. These are called learning rates. And it's a measure of the decrease in price in something over the kind of cumulative deployment. So as we install more solar energy, the price of solar drops. As we install more offshore wind, the price drops. As we install more onshore wind, the price drops as well. However, the learning rates of these technologies extrapolated out over a decade are of the order of kind of 34%, 16%, and 10%, which is, fantastic, but not significant at the level that we need in order to, have 34 gigatons of impact. So while these technologies are very much the core focus of solutions, and decarbonizing electricity generation is on the critical path of our solutions for climate change, we also need technologies that can scale at a level that exceeds this. So if we are to compare scaling in AI, so one of the most state-of-the-art language models currently available is BERT, and the scaling of AI as a software technology is completely different. So the AI community is generally an open source community. We release developments. In order to keep accelerating, it's heavily influenced by research and academia. It's really emerged from there, and you'll see a lot of the leading figures in industry also come from academia. People like David Silver at DeepMind, who's from UCL originally. So again, it has this kind of open source academic kind of mentality. And Hugging Face is an open source community that is supporting state-of-the-art developments in language modeling. And their technology has been downloaded 29 million times in a month. Now compare that to the deployment of solar technology. There's no comparison in terms of the scale that you can reach with a software technology. And to take the analogy a bit further, things that Facebook took 7 years to hit 1 billion users. TikTok has taken 4 years to hit 1 billion users. So software technologies inherently scale. And this is why they're such a critical aspect of the conversation on climate change. But what can you do with them? So in terms of accelerating deployment, the speed of getting those things out is big. But in terms of impact, what's the potential for scale? So I'm just going to talk about two different applications. So again, there are a multitude of different applications, and one of the great things about training students and working at a university is you constantly come up with students who have new ideas about ways that AI can be applied in the system to reduce emissions. But whatever we do, the power sector is always going to be at the vanguard of decarbonization. It's on the critical path, and deploying renewable technologies there and decarbonizing electricity generation is fundamental to a lot of solutions. The power sector has been the single largest source of emissions in the UK, only recently eclipsed by transport. And the grid itself is described as the most complex machine ever built. It consists of connections of miles and miles of cables, all interacting, all operating with a commodity that can neither be stored nor rejected. It has to be consumed at the point of generation. So this is an incredibly challenging scenario. And as we add renewables to it, we're increasing the complexity of operation. we've had 80 years to learn how to operate grids under dispatchable generation. And, we know how to do it very well with coal generation and gas generation. We have to learn how to run grids with renewables while we're doing it. We have to kind of build the plane while we're flying it. So in that sense, we need new tools that can help us in this. And one of the research projects that UCL was involved in helping with was learning to run a power network, which is a challenge at NeurIPS, which is the largest AI conference in the world, challenging AI teams around the world to develop an autonomous agent using reinforcement learning to operate a grid under a range of scenarios. And the winner was whoever could keep the grid from falling over the longest, as we kind of poked and prodded it with different scenarios. So it was won by a team from Baidu, and it shows kind of how big tech can kind of interact with, a power sector to develop new tools that help us, adapt and move forward with climate change. So the level of improvement that's available within the grid is significant. 1% improvement in operational efficiency correlates to millions of tons of CO2, which is what we need. So, and again, if you think back to the Hugging Face example, once that's developed for the UK or for Germany, who's to say it can't be downloaded and scaled for South Africa or Australia or places like this once the software technology is developed? So again, the opportunity to have large impact and then to quickly deploy and accelerate its adoption all over the world are the key characteristics of AI as a software technology. And again, focusing on scale. So if you were to look at areas where it's possible to have a big impact on emissions, the energy intensive industries, loom front and center after power generation and transport as one of the areas where, big innovation is needed, but there's also big potential for reduction of emissions. So the scale of opportunity is on the gigatons level. So energy intensive manufacturing of things like steel, cement, they need high grade energy from fossil fuels to reach the temperatures that are needed to melt the kind of materials down. And they're responsible for 20% of global emissions. So as a single point where innovation can happen, they're a really attractive opportunity. And they're one that we have focused on at Carbon Re, a startup that's been launched out of UCL and Cambridge. So to give a bit of an example of what we're doing, the opportunity in this space that we see is down to the variability in energy intensity of manufacturers. So plants, just like everybody, have good days and bad days. So one day they're operating at a really high energy intensity level, and the next day they find a way to run production at a much lower energy intensity level. And the numbers you're looking at here are gigajoules of energy per ton of cement. And a plant typically produces about 4,000 tons of cement a day. So the energy consumption is huge. Now, if we look at the variability over time, and if we look at that ranked, we can see if you can move from your worst decile performance towards your best decile performance, the scale of emissions reductions is huge. And what if we could make every day a good day? So that's what we're doing at Carbon Re. We've developed a software product that we're using to decarbonize the foundation industries by helping them in operational efficiencies and helping them to reduce the energy consumption and bring it more like what they're doing on a regular basis. Make their bad days look like their good days, make their good days like their best days. So again, this is something that's been spun out of UCL, and I'm really proud to be involved in as a kind of an application of research having impact. We've raised 1 million in investments, and we've got 5 pilot projects happening around the world. And again, we believe the opportunity is in the gigatons for impact, with 20% reduction in fuel-derived emissions and savings per plant. So again, the solution is all based around artificial intelligence. What we do is we have a digital twin of the factory, in this case a cement factory, where the data I've shown you is taken from. And what we do is develop a recommendation engine. So we have an AI that learns what the differences are between the good and bad day performances are, and identifies the actions that need to be taken in order to move those bad days closer to the good days. And it works with the human operator to give them advice as to how they can achieve this. So it's a full human in the loop solution, leveraging artificial intelligence to have impact today. So just to conclude with a few ideas, and again, I would kind of, as you might expect, I'm quite bullish on the opportunities for AI in tackling climate change. However, we also need a lot more people. So again, at the intersection of people who know a lot about AI and the intersection of people who are working on climate change is very small at the moment. We need a lot more people focused on this. And there are lots of reasons why we talk about responsible AI, but we should also talk about responsible AI researchers. Is it a responsible use of kind of your knowledge to go and optimize the deployment of ads, or is it a more responsible use of your hard work and energy in tackling the biggest problem in the world? And again, a lot of AI has developed with specific applications in mind. As we look to tackle other problems, there'll be new directions for AI around causal reasoning, interpretable AI, model explainability that will help us deploy AI in the energy sector a lot more. And again, there's also the idea of redeveloping the energy system around AI. So we're looking right now to see what we can change and what we can do quickly. But what if we were to re-engineer the entire system around the characteristics of a software solution that never gets tired, can react at a scale far exceeding human operation, and do things that so far we've never been able to do in the past. So yeah, thank you very much. I think I ran slightly over time, but happy to take any questions now.
Thank you very much, Aidan. That was fascinating as well. So thanks to all three speakers for some really provocative and interesting ideas. Thank you for those of you who submitted questions. It's not too late. We're going to go into the conversation now. If you want to submit a question, please go to Slido, that's sli.do, and search for your hashtag UCL climate. So let me get the conversation rolling, perhaps with you, Aidan. Derek Young has submitted a question saying, is the main contribution of AI towards climate change mitigation just reducing or eliminating wasteful inefficiencies in energy intensive processes? So I think we're starting to get into that, shouldn't we be reducing energy as well as mitigating by reducing inefficiencies? What's your kind of thoughts on that?
That's a really great question, and there's a lot of kind of discussion around the right kind of fuels. In order to meet climate change or to mitigate climate change, it definitely needs a mix of technologies. But I'm of the view that efficiency is the best fuel. Not hydrogen, not kind of nuclear efficiency. So the watts you don't consume should be counted as kind of negawatts in some sense, and reducing this is massively impactful. So doing things better, and it's again, it's down to the kind of characteristics of a software solution. It doesn't require capital investment. You might say the ideal solution is for everyone to operate on hydrogen. Well, there are 3,000 cement plants in the world. How long do you think it takes to convert them all to hydrogen? It would take a long time, years and years. So, and again, where does the source come from? So in terms of having action immediately, definitely reducing energy consumption is the main way to have quick action.
Thanks. And let's come on to Kate then, because I couldn't help but noticing in your presentation, on the one hand, we're monitoring Amazon deforestation, but on the other hand, we're doing it by putting satellites on rockets into space. And last time I looked, rockets weren't the most carbon neutral technology. So how do you think in that biodiversity space about balancing the energy consumption with the benefits?
Yeah, I think it's a really interesting question. I really do think that that the scale of the kind of monitoring and, well, not just monitoring declines, but restoring habitats is so huge that it does counteract the kind of carbon that was taken to put it into space. And those weren't put into space for deforestation monitoring. They were put in for more commercial uses. We're just using them for that. So I guess what I'm saying is that there's this human in the loop, as Aidan was saying, human in the loop, smart sensors that can optimize our understanding of the habitats, and actually what actions are successful in increasing biodiversity and increasing health or storing carbon. And I think that's really important. So it's not just about monitoring your decline, but it's managing your system better. And I think we're so behind in the ecology, in the agriculture sector, in the forestry sector. We're like totally way back compared to just what I've just seen from Aidan, and monitoring, efficiency of uses. We have got nothing like that cyber-enabled systems, nothing at all across the planet.
So you're seeing a conceptual similarity there between his energy intensive processes maximizing efficiency in megawatts. You're seeing that as a potential future for managing biodiversity and managing ecosystems. Yeah,
I wouldn't say biodiversity, I would say ecosystems, because it's just much more than the function of which cute cuddly species you want to manage. It's more about having functional ecosystems which can store carbon, are resilient to, you know, massive climatic effects, that can support our health and well-being. It's much more about particular species. It's more about the earth system that we need to be supported by.
Great. Let me bring Geoff in then. I mean, we're talking essentially about that balance of incentives between energy consumption and energy efficiency. And I guess one of the surprising things when you told us about your policy initiatives, you didn't say carbon tax or anything like that. What's your view on something like an incentive like that to help us reduce our carbon emissions?
Well, where we have achieved fundamental change, as we've done on waste in the last 20 or 30 years, it's been a combination of things. It is rules and laws and taxes sometimes, which have forced industries to recycle 50, 60, 70% of glass, paper, plastic, etc. Plus behavior change, people themselves deciding to change how they lived and what mattered to them, and market competition to drive new technologies. And it's exactly the same, I think, on everything in relation to carbon. 15, 20 years ago, we worked on carbon taxes, and in Australia, I was part of the team with the Prime Minister who introduced them with a huge backlash. So they've been sort of on the agenda for 2 decades without really yet the political will to make them part of the package. And that's why the sort of things Aidan was talking about are so important. At least you can get on with them, and there's direct bottom line benefit to the electricity company or the cement company, and so on. Can I just raise 2 other things which I think maybe link all of our commentaries? So as I think Aidan said, you know, the best minds of the last generation, I think it was Jeff Hammerbacher of Facebook said, were devoted to click-through advertising. But I think we could use a whole generation of new AI tools to prompt us to think or behave in different ways. Fast fashion is a good example, less than 1% recycled now. You know, when you're making a purchase, can you be prompted towards a less carbon destructive clothing option? We're seeing this in science, where the productivity in R&D has been in a long-term decline for decades, but AI is being used to prompt new kinds of combinations, the things we know in protein, which DeepMind and others have worked on, but also for scientists working in other fields to think of where there might be a connection with other knowledge, how to speed up the productivity effectiveness of the very core activities of science. And I think these are quite exciting. They're underdeveloped as yet, but they're the equivalents to what has been done so successfully by the social media companies. And then very finally, on Kate's point, one thing which was briefly mentioned in COP26 is the idea that in future capital assets will be linked to objective monitoring of the state of deforestation or below canopy behaviors. And that's quite an interesting new version of capitalism, which actually doesn't go through complicated ESG reporting, but actually is more objective in rewarding, incentivizing the right kinds of actions on biodiversity.
Fascinating, really interesting, and thank you very much. Have any other 2 panelists got any responses to Geoff on that, or shall we move on?
Yeah, I guess I would come in about value chains and supply chains. I think that's a really important point that you made. Well, you made lots of important points, but I think I'd like to pick up on that one, just because I think there's a huge market for that, because there's a huge appetite for having sustainable goods, and using kind of new technologies to be able to monitor where the supply was, how effective, you know, local governance is, local community involvement, how that's being managed, your local resources are being managed, and that can be tracked back right to your, you know, new cardigan or whatever. I think that's really important, and I think that's a really, really excellent use of these kind of value chains through the system.
I mean, Geoff, I can't get away from the nagging suspicion this is all about encouraging humans to do more, and there can be negative consequences of that as well. So your beautiful vision of a land of driverless cars and that was going to be great. We can equally think, I've had people point out to me that rather a handy thing about having a driverless car is you don't need a parking space, because you can just have it drive round and round and round while you're in the climate change lecture and pick you up at the front entrance when you're finished, which of course would result in lots more congestion, lots more energy consumption. So I guess my question is, isn't the key at the end of the day human behavior? and persuading people to do less, to not buy the cardigan at all?
And that's definitely part of it. And I'm sure everyone watching this call probably buys lots of things we don't need. And one hope is there will be just a profound culture shift away from waste and excess consumption, including at the very top 1% or top 0.1% who often own 10 homes they only use a few days a year, and probably own 10 cars, most of which they don't use at all. We have a chronic problem of deep waste built into our economy at every level. But I think in terms of driverless cars, I don't think that is about behavior choices. I think that is more about designing the architecture of daily life. And it's true, and we found this with Ubers, that they may all drive around waiting for lifts, but in that vision of a future city, you probably won't need huge multi-story car parks with huge spending on cement to build them. You won't have shopping malls in quite the form you did in the past. You won't have parking spaces all over the place. So there's all sorts of resources can be liberated by that AI-enabled transport future. The key is to look at the net effects, because they often are, as you say, a bit surprising, and they have been in the past. Things you save in one part of your consumption patterns, you then reallocate the spending to something more carbon intensive. And this is where intelligent analysis of net carbon effects is so important, because it is quite counterintuitive often what really happens. And I think nowhere more than in the cloud, which we are all part of at the moment, so I think most people still think has no real footprint. They don't realize it's based on vast server farms, enormous mining of minerals, and the kind of Kate Crawford in her brilliant recent book on the Atlas of AI shows just how much this is a very material technology, even if it appears immaterial.
Fascinating. And let me pick up, Aidan, on another aspect of human behavior that you touched upon, where I think you're exhorting people to not go and necessarily work for solutions that would serve more adverts to us, so we bought more cardigans. But you were very much a proponent of working on presumably socially useful things. How would you encourage that beyond just saying that's a good thing? Is there actually anything you've identified that we could do to encourage those kind of behaviors?
I think the community is kind of waking up to that, I think, a little bit as an option. And I think, I guess the challenge is a little bit that tech companies offer such attractive salaries and such big perks. It was definitely, the last decade, it was the case of, if you were working at Google, that was like the best place to work. And I kind of feel like that is kind of changing more generally now in how things are viewed and their impact on the world. It was kind of that the bigger picture is being considered, and hopefully that will peter through into kind of the AI community, and people will start to look at what they would do or find more meaningful. And I think it's been maybe an outcome of the pandemic as well, of people reevaluating the choices they've made, the jobs they're doing, thinking about other ways of working and thinking about other things to work on, and what gives kind of satisfaction and a sense of achievement to them. And again, you have to provide viable alternatives. It's no good just to say, this would be good, and kind of walk away. At Carbon Re, we do want to bring in the best AI and machine learning talent that we can find, and give them the opportunity to have gigatons of impact on emissions. So that's kind of what we're doing. I think the investment in climate tech at the moment that we're seeing shows that there's a real appetite for investors and venture capital firms for these kind of companies. And again, I think, coming back to give Google a hard time, they had this mantra of don't be evil. That's no longer good enough. That's kind of now that's like obvious. Before it was kind of a groundbreaking thing to say, what a great company, don't be evil, do good things. But now it's kind of a case that's expected, and what can you do that's positive, not just don't be negative.
Thanks. That's really full of some really interesting points that I'm sure will fascinate everyone who's listening. I want to move on a little bit. We've got about 10 minutes to go and tackle a couple of areas. One is going back, Geoff, to your point, which actually resonates with what Aidan just said about big companies, that they lock up a lot of data. And we have a question: should there be a requirement for AI data to be open source to ensure transparency and as a way to corporate social responsibility for companies that might be a little more reluctant? So should we be mandating that? Or perhaps to pose it as a question, Geoff, how would we persuade Uber and the bus companies and everyone you're talking about to open up their data and create these data trusts?
I don't think we'll persuade them, because I don't think in the current market dynamic, it's really in their interest to do so. Every past industrial revolution required new rules of the game, new laws, new regulations, and so on. And the one we're entering, the fourth industrial revolution, is no different. My preference would be that any company running essentially essential infrastructures in energy, transport, but also actually the main platforms, should have requirements to open up their data through APIs of some kind, with anonymization or privacy enabling, absolutely crucial, in order to enable the kind of coordination and planning at a city level or national level, which will be so essential for achieving net zero. And there are some precedents. Versions of this have been done in banking. The UK was a pioneer of open banking data, allowing us to sort of take our banking data, give it to a third party. The European Commission is looking at something quite similar as part of its AI rules. Now, even 5 years ago, this was all unthinkable. I published various things 5-10 years ago about this, and they were deemed utterly, on the margins. But they're now quickly becoming mainstream. And I think even Google actually and Microsoft both realize, I think, that this is the direction of travel. And they probably can make plenty of money in a new environment, but it will probably take us a few years to get there. What we're still missing is the good enough designs of the guardians of that data. And the same is true in health. We saw this last year around COVID, although we moved quite quickly to free up some of the health data. We lack rather the trusted intermediaries who we can feel confident will protect that data, protect our privacy, but also maximize the value to us of linking that with other data sets to get to better cures or better solutions to climate change. And this is, I think, one of the great challenges where political science meets technology.
Interesting. I like that idea of open banking. I was thinking about open energying, where we take our personal carbon footprint with us as we change providers. And just to follow up, though, I mean, I agree that trust is not perhaps at a high level in our societies, either with some companies, or many companies we might say, but also to some extent with governments. And there is a lot of frustration amongst citizens about that. So what steps do we need to do to build those trusted intermediaries? Because it's an urgent task, if I've understood you correctly.
Well, I don't think it can be the government. We're never going to trust ministers, and it can't be the companies on their own, especially after Facebook in the last 2 or 3 years. So again, this has happened many times through history, where there's been a need to create intermediaries, third-party bodies, which have a really strong ethos and competence. We have them around central banks, we have them in our regulators, we have them in bodies like the BBC. There are lots and lots of precedents of creating institutions designed to be trust building in a which is neither the government nor the market. And we just need a whole family of those now for data and AI, I think.
Good. And Aidan, just turning to you, we were talking about open data here and open energy. You work in the energy industry. Is that something you see as an opportunity, really, to be much more open about energy usage and along the lines Geoff says? Or are there some barriers in your industry or in your industries where you do your academic work?
The energy sector has been transformed by digitalization over the last few years. There's been a number of reports, Energy Data Task Force, things like this instituted by Ofgem. And it's interesting how they've gone about it. I think they've gone about it in quite a nice way, in that they've tried to benchmark companies against each other. So every district network operator who manage the local grid, they have to publish a digitalization strategy, which they can then evaluate, compare, score, and say, well, the best people in this, the best report came from Western Power, and the worst was from UKPN, and we're going to put pressure on UKPN to do better, for example. And that's a nice way, and I would like to see something like this. Again, regulation needs to have teeth. There needs to be sufficient powers for regulatory bodies to have impact in the space, and that can be quite challenging when technology moves quickly and it's hard for regulators to keep up. And I think engaging with academia is one way for them to really even that out. And I think it's something that we would probably like to see more of, rather than academics working for big tech companies. Have them work with regulators to keep them at the forefront of technology and to design the right policies and right structures around having impact.
Mm-hmm. Very, very interesting. Now we're moving into the last 5 minutes or so of our discussion, and I just wanted to tackle one final area, which is it strikes me that, and maybe we'll come to you, Kate, that AI is very much a technology of developed economies. And here we are sitting in a developed economies. But we also hear, or at least I hear, from COP26 about marginalized communities, about the global south, and about the applicability of these technologies in that area. So I think my question is, how do we, thinking again about Slido, how do we ensure we include communities on the front line of climate change, and how we ensure that the AI isn't just a developed economy technology that is being used to deliver unsustainable solutions? Kate, I wonder what thoughts you have about that.
Yeah, I mean, I did see that at the COP, and I think that's a really a welcome development that got some airtime in talking about the targets and inclusion, especially for the deforestation target included in Indigenous groups, and that was really great. I think there's an actual positive role, I think, for local Indigenous communities in AI. I think there's a lot of tools which can make their knowledge really useful, and so they can use those tools to manage their own resources. And I think that's really, you know, there's new technologies that they can use, but also I think there's a kind of training gap which needs to be bridged. So I think that there's going to be the need for more investment in those kind of training opportunities for those groups. But I also think there's a huge opportunity for them. They can leapfrog a lot of these technologies. And, you know, if they can get trained in those areas, there's a huge opportunity for them to be at the forefront of some of those solutions for tackling climate change.
That's a really interesting possibility. It reminds me of the growth of mobile banking across many areas of sub-Saharan Africa. Aidan, looks like you want to come in here.
Yeah, just quickly. I mean, if you think of the contribution of the industrial world to climate change, you know, we've been the ones driving it. You know, it's the cumulative emissions from the UK, America. You know, they dwarf the rest of the world. And in some sense, AI is an opportunity to give back and to kind of, you know, distribute technology that, you know, we've been developing and that has been largely developed here, and it's easy to hand over to other countries. For example, you know, the best solar power forecasting algorithms should be distributed, you know, from National Grid to Colombia to, you know, South Africa to places like this, to let them progress and to let them have a benefit from the advantages and the research that we've invested in and reduce their emissions. And yeah, I'm afraid I have to jump off now, but thank you very much.
Thank you very much. And Geoff, maybe a final thought from you.
Yeah, so one of the projects we're doing at UCL at the moment is with the UN and UKRI is mapping global R&D and how well or badly it aligns with the Sustainable Development Goals. And that, of course, shows enormous imbalances between the poorest countries and the rich, between the biggest companies, even, and governments, and huge imbalances in terms of where the brain power and the money goes. We're hoping to turn this into a more permanent kind of observatory, so at least we can know where AI research money is going. At the moment, that is very opaque, very little discussed, very little accountability, but also to help promote exactly the sort of things Kate was talking about, these flowering fields where citizen science, collective intelligence, plus sensors, plus AI come together to transform the patterns of power in fields like biodiversity. And IPCC is always also beginning to tap into Indigenous input. So things are moving in the right direction, but the imbalances are enormous when you actually look at the numbers.
Very sobering. Right, I think sadly our time has come to an end in this lecture, but I hope you've got a sense from our three panelists of some of the things we're thinking about at UCL, some of the things we're doing at UCL. And I would like to thank Kate, Geoff and Aidan for their wide-ranging knowledge and expertise that they applied in this discussion. And also I think for the sense of optimism combined with realism, I think in this very difficult and challenging but extremely important issue. If you liked today's lecture, you may be interested in the next lecture on Tuesday, the 23rd of November, also 1 to 2 p.m. And that will be on health and climate change, a very important topic, and we'll be addressing how can tackling climate change improve your health, ? But for now, thank you again to Kate, Geoff and Aidan, our speakers. Thank you very much to the audience for listening, and we'll see you again on a lunch hour lecture near you soon. Goodbye from me.